Okay, so I think you liked making this and playing with this, right? So you can, after the talk, you can see again and then uh, you try at home. So now there is the last very interesting talk, what I was mentioning in morning, that searching for friends outside. So that Vishal will talk to you about this. So he also did his PhD with that telescope GMRT in Maharashtra. So he did his PhD there. Now he is doing, that time he worked on pulsars, what I was mentioning in the morning, neutron star. Now he works on pulsars, obviously, and there are other things, very explosive radio burst, searching for friends, and lots of things. So I'm sure you will like what he has to tell you. So let us start. Thanks, Vishal.
Thank you. Good evening, everyone. My name is Vishal. I hope you are not too tired for this talk. I'll try to keep it brief. It's a very short talk. But I like to keep it more of a discussion or an informal thing. So please do not hesitate to, stop me in the middle anytime you have any questions or any comment or anything. Feel free to do so. So today, I'm going to talk to you about one of the most fundamental questions of science. Most of you have already probably thought about it some way or the other. What is this question? So if you look at the sky, you look at the night sky, what do you see? You see stars. Our ancestors also, when they first looked at the star, they wondered that is it possible that we live on this planet Earth, is it possible that there is life on those stars? Is it possible that there is intelligent life on those stars? The question of other life in the universe, or in some way, are we alone in the universe, is actually the most fundamental one. It's one of the most basic questions that we have asked science since the beginning of it. So how do we explore this question? How do we answer this question? So I'll try to actually give you some of the recent work that we are doing in order to answer this question. And that might give you a hint of what are the different things that maybe you can contribute in future, in the next generation, to answer this most fundamental question in science. So we know that we all live on this beautiful planet Earth. But if we ask this question, are there other planets on these stars that we see at night? So how do we find that? I mean, we have to first ask this question, is Earth very unique, or is planets very unique? So we go and first find, is there any other planets out there? How do we find a planet? There are different ways on finding planet. Some of the very basic technique is this one. This is called the transient technique. So what people do is that they look at a star. If there is a planet around a star, and if the planet comes between you and the star, the light from the star actually dims. It goes down by a small fraction. And based on that, you can actually find out whether there is a planet around a star or not. In fact, you can do even more. If you have a giant planet, the dip will be even more. If you have a tiny planet, the dip will be smaller. So you can say a whole lot about the planet around these different stars, not just whether they exist or not. This is one of the technique. The other technique which people routinely use is called radial velocity. So planets are also massive. Some of these planets are so massive that they actually pull the star towards them. And in fact, what happens is that the stars and the planet rotate around a common point. And that actually causes the star to wobble a little bit. So what happens is that when the planet is on the opposite side, the star is actually coming towards you. So the light from the star gets blue shifted. And then on the other time, the light from the star gets red shifted. You all know about the Doppler effect, right? You probably heard about it or probably did some experiment with that. Not really? Okay, sorry about that. But there are ways in order for you to check that if the star is coming towards you or going away from you. And based on this motion, you can actually understand that whether there is a planet around a star or not. So this is the second way by which you can check that. Third way is obviously by directly taking a picture. If the planet is bright enough, if planet has its own light, you can actually put a slit, or you can actually obscure the light of the star and see if there is something else pops out at the next to it. This is a third way. Although there are not many planets found using this technique, most of the star has been found by using the first two techniques I discussed earlier. The fourth technique is using, this is also one of the most explored, one of the most extreme techniques, and there is only one planet people have found so far using this technique. So what happens is that there is a background star which emits light. Now this light, when it passes close to a star, it actually bends. The light rays itself bends due to the gravity of the star. Now if this star has a planet around it, the bending will have an extra effect. So you can in fact find a planet using that technique as well. So we have all these different techniques. So what did we find? We found currently around 4,000 planets around all those stars that you see in the sky, and we haven't really explored all of them yet. We have only looked at only few of them, and we found all of these planets. Now the question comes, if there are so many planets, are there any planets which look like Earth? So what we define as an Earth-like planet is actually this particular type of planet which is not too close to their star or not too far away. There is this one very sweet spot where you would like the planets to exist. Now this spot, actually this ring of region, we call habitable zone. In this zone, if a planet is inside that zone, that means that life can start. The water can exist on this planet, and life as we know it can exist as well. So what do I mean by that? So let's say this is a planet. If it's too close, the temperature is too high due to the radiation, due to the heat of the star itself, that water will evaporate. So water will not exist in a liquid form. If the planet is too far away, the temperature is too low that water will freeze, and they will only see ice. For life, we know it that we need water. And if you want water, that means the planet has to be within certain range from the star. So this is what we call habitable planet. We have not found many of the planets within habitable zone, but that is just a selection effect. We haven't really explored that much. We are still in a very early stage. And I'm sure in future, we will, by the time you will reach to you will graduate, I'm sure you will have a whole list of habitable stars, or habitable planets in a database. So there are, in fact, we have found many star systems, just something similar to our system as well. For example, this is a Kepler 90 system. Just like our own solar system, we have a Mercury and then Venus and Earth. They also have a bunch of planets, and some of these planets are inside the habitable zone. So this is one of the examples. We have found a few of these systems like that. In fact, we have found something around 50 planets which are similar to Earth, and they are inside this, what I define as the habitable zone. So that's interesting. That is telling us that Earth is not unique. There is nothing special about Earth. That means that a planet like Earth can exist elsewhere. Now the question comes, if planet like Earth exists, can life also exist at other places? How do we find that? So we look at the night sky. What you see is basically stars, but actually we now know that stars have almost all the stars are planets. So your night sky is full of planets. The question comes, still the question remains, are we alone in the universe? How do we find life? There are ways to find life, and I'll talk about, for the next few slides, I'll talk about how do you find life on these planets. If I give you a little bit of example, how the life started. So life basically started from a building, some of the basic building blocks, which came during the formation of our planet. So when the planet was getting formatted, some of the basic building blocks were already there, and due to some of the chemical processes, we know, although there are some gaps in our understanding, we don't know completely how life started, but we know the basic building blocks were already there. So we basically had all the raw material there, and from there, the life actually started. There is one more very interesting thing about life, is that life actually exists in a very extreme environment on Earth. We know right now. There are places where you do not expect life, where you do not expect to find life, but they do exist. So this actually is a good thing for us. That means that the definition of life we have, or the habitable zone we have, may not necessarily be applicable universally. Maybe there are places where life is still in existence, even though the conditions are not desirable for us. So That means that we shouldn't actually limit ourselves in searching for life only inside the habitable zone, because we know that there is life exists in extreme condition on Earth as well. How do we find life then? Now, this is a very big question. We don't know what life looks like. What are the byproducts of life? Only thing we know is that what life like us produces. So what we can do is that we can go ahead and search for things like that. For example, life on Earth, we all know that we breathe oxygen, right? And Earth has a lot of oxygen in its atmosphere. Earth also has a lot of ozone in its atmosphere. Both of these are byproduct of life on its surface. So if you find ozone, for example, on an atmosphere on some extrasolar planet, some planet of the other star, that is a very good sign that that there might be life on that planet. How do we find that? So people are thinking about these various different ways. One of the ways, so you all did a just like a moment ago, you were all trying to do this spectroscopy experiment where you're trying to see different lines from a reflection from a light. This is something similar to that if you have a planet between the star and you, the light from the atmosphere of this planet also have these different features in them. And you can look at these features in order to understand what's inside the atmosphere of these planets. And if you find ozone or some of these other chemicals, we can in fact say with certain accuracy that yes, it is possible that that planet might have life on it. So this is a good thing, but still, this is only a first step. This will only tell us, and I'm sure that within the next 10 years or so, we will definitely have planets for which we would have found ozone or some kind of other molecules which will directly hint us towards the existence of life on that planet. But the question still remains, are we alone? Is there any intelligent life? How do we search for it? We know that on Earth, when life first started, it took it several years for it to evolve. Is it possible that on some of these other planets where life started, it also evolved and then it reached to an intelligent stage? We know that, yeah, it's true. On Earth, once life started, when there is life, it evolves automatically. Or to famous this quote, life finds a way. If you have life, there is a high chance that the life will become intelligent. So that means that there is a high probability that there is intelligent life in the universe. Question comes, how do we find it? People are suggesting various different ways in which you can find intelligent life. One of these ways is that, so I already discussed this with you, that if you have a star and you have a planet going around a star, the light from the star actually dips a little bit. There is, in fact, a star in which people found not just one, but multiple dips of different intensities. And some of the time, the dips were quite irregular. There was no periodicity in it. So what people speculated is that it's likely that there is some kind of an artificial structure. Now, this is a hypothesis, obviously, suggested by Freeman Dyson, that if the life on those planets evolved enough, they could build a whole structure around their entire star. This is what they call a Dyson sphere. If you have the structures like that, that structure will produce patterns like this. Although later on, when people did more observations at different wavelengths, they found that it's in fact a gas, random gas clouds, not a mega structure. But this is just one of the ways by which you can find if there is any kind of intelligent life on other stars. The other thing is that we will look for signs like, for example, Voyager. How many of you heard about Voyager spacecraft? Can you raise your hands? So that's very good. Most of you heard about Voyager spacecraft. So this is a spacecraft launched in 1977, and it's still traveling. The spacecraft is currently outside our solar system, and it's still traveling further. If there is an intelligent life somewhere on other planet, if they happen to find Voyager, they will know that this was not naturally made. This was made by an intelligence life. This was made by an intelligent civilization. So what we did, we in fact put a message on board Voyager that if there is an intelligent life somewhere else, they find Voyager, they would know about us. They would know about our position. We did something very smart. We in fact put a position of the Earth based on different pulsars, because pulsars are unique and they are universal, so the other civilization might also know about them. So it actually points towards Earth. So whichever civilization in future might find Voyager, they would know where it came from. can we do this other way around? Is it possible to find something like this in our own solar system? Maybe true, but that is still a far-fetched idea. It will require a lot of a huge amount of effort. Maybe we can do something like this in future, not right now. So how do we find it? How do we find signs of intelligent life? So one of the ways people argued that you can very easily find intelligent life is by detecting an electromagnetic signal. You probably know, I don't know whether you know about this, but there are electromagnetic waves. For example, the light that is coming towards you through your eyes, this is an electromagnetic wave. The mobile phones that you're using, that communicates with radio waves. That's also electromagnetic. But they come at a different frequencies. The light through which you are able to see is actually the high frequency of the electromagnetic waves. And the radio waves that we use to communicate using your phones is the low frequency radio wave, low frequency electromagnetic waves. So these are the different electromagnetic waves. It goes from radio to all the way up to gamma rays. So people thought that electromagnetic waves, in fact, there are a lot of arguments on this, is a good way to communicate over larger distances. So maybe if there is intelligent civilization on other planet, they can use electromagnetic waves to communicate with us. Among all the electromagnetic waves, we know that radio waves are even better. Radio waves can penetrate through mediums. Now, unlike optical and other high frequency electromagnetic waves, which might get absorbed in the medium, radio waves can penetrate the medium between us and the star. So radio waves are a very good way to communicate. The other good reason for us to use radio waves is that radio waves can travel without any interruption throughout our atmosphere, unlike other electromagnetic waves. So what I'm trying to show here is that this is a different electromagnetic frequencies. This is the radio frequency, and this is the high frequency electromagnetic waves. And what I'm trying to show in the blue color is actually the way in which the atmosphere allows these waves to pass through. So most of the low frequency radio waves do not pass through it. Most of the frequencies higher than radio waves also do not pass through it. There are two windows to look into the space, and these two windows are, one is in optical light and second is in radio. So there are two windows through which we can study the universe. If you want to study the universe at other wave band, you probably have to go to space. For example, if you want to study the universe at gamma rays and X-rays, ground-based telescopes are not very good at it. So you probably have to go to space in order to get the right amount of photons you need for your study. There are different telescopes operating at different wave bands. So I mentioned about the electromagnetic wave. In order to capture this electromagnetic wave, you need telescopes. You probably all have seen an optical telescope, a light telescope, through which you have seen the moon or Jupiter, right? There are also telescopes which operates in radio, which actually captures radio waves from space. So we can use, in fact, the radio. So this is one of the examples of a radio telescope. Radio telescopes are quite good at capturing even a faint amount of radio waves, which none of us can detect it using our smaller equipment. So the type of signal that we are trying to detect are so weak that we need a huge amount of area to collect all the radio waves. So there are big antennas, size of like something around 100 meters, 500 meters in diameter, which is enormous, to actually study the universe. So that means that we can use this radio antenna to study if there is any civilization out there or not. If there is an intelligent civilization out there, and if it is trying to communicate with us using radio waves, we can capture that. So we are trying to search for these two different types of signal. This is one of the antennas that I was just referring to. This is actually an Arecibo antenna near US. It's actually 300 meter in diameter. So you can imagine this is actually 300 meter in size. So that's quite big. So this antenna is so powerful that if it transmits a signal, you can actually find the signal all the way across the galaxy. Our galaxy is huge, it's massive. We are actually in a very small part of the galaxy. But this antenna is so powerful, and the type of signal that it can transmit can easily be identified and easily be found all the way across the galaxy. Now you can turn this argument around. If there is intelligent civilization in the universe, if they have a telescope similar to Arecibo, they can transmit a signal which will easily be identified by us, which we can easily identify and we can easily find. So if ET is trying to communicate with us in a deliberate manner, they might try to send a very strong signal, which we can easily pick out. The other type of signal we try to search is what we call eavesdrop ET. In this type of signal, we are not looking for a deliberate transmission. Now, I mentioned that we all use our mobile phones. This mobile phone signal actually not just travels to you, but it actually also travels in space, and it keeps on going. Similarly, TV signals, radio signals, all those sort of signals that we use in our daily life actually doesn't get limited on Earth only. They travel in space. So there is an expanding bubble of radio waves going from Earth from last 70 years. Is it true? Can it be possible that other civilizations out there in the universe may be using radio waves for their own communication, and can we capture that radio waves? The answer is yes. If the radio waves is strong enough, we can capture it. And how strong it needs to be. For example, I give you some of the examples that we know on Earth, which are so powerful. For example, some of these antennas. This is an antenna close to San Francisco. It's called Sutro Tower. This is so. Sorry? Yeah. No, we don't have any detection, so we don't have a proof that yes, it's possible to detect it, but you can calculate the signal strength. So this is what I was just coming to. You take the signal from this antenna, and if you look at the strength of the signal, you can detect the signal from this antenna all the way up to few light years distances. So if there is a civilization within a few light years from Earth, they will detect this signal from this antenna. So we can turn this argument around. If they have antennas like this on their planet, we could detect them very easily. There are even more powerful systems that exist on Earth. For example, the planetary radars. What we do is that we actually want to understand our solar system. So sometimes we actually transmit powerful radar signals in our solar system to our solar system objects. Now, these are very powerful radio waves. If we are able to these signals are so powerful that you can, in fact, listen to them even across the galaxy. So similarly, the same arguments applied. If the ET is trying to explore their own system and using radio waves, we can capture that. We would know that there is a radio waves coming not from Earth, but from extraterrestrial civilization. So these are the two different types of signal that we typically search for. How do we do that? So this is a massive effort. This requires a lot of computation, lot of telescope time. And in order to do that, in 2015, although this effort has been going on for many, many years, in 2015 we decided to do this more rigorously. We decided to do this in a more detailed fashion. So for that, there was an announcement for a huge amount of grant to do this project. This was announced as a breakthrough initiative. You probably all recognize late Professor Stephen Hawking. He was one of the lead founder of this initiative. And we started this search from 2015, which is still going on right now. In order to do this search, we use a different radio telescope in the world. This particular program, which we actually use to do this, to look for a signal from extraterrestrial intelligence, is called Breakthrough Listen. Breakthrough Listen actually uses different radio telescopes. So what do we do with that? So there are different science goals. So as I said that we wanted to do this program in a more detailed fashion, which nobody had done before. So what we wanted to do was that we first wanted to look at all the nearby stars. So we live in a galaxy. Our galaxy has so many billions of stars, right? We can't look at all of them. All we can do is that we can first start looking at the stars which are closest to us. So what we thought, let's try and first look at the closest million stars. So that's one of the targets we have. We also wanted to look at the entire galaxy, our own galaxy. We also wanted to look at all the galaxies close to us. So why do we limit our search only to our nearby stars? We can, in fact, also search all the galaxies which are close to us. So we do search on these targets quite frequently using these telescopes. So I mentioned that these are the radio telescopes which are quite big in size. For example, this radio telescope is what we call the Green Bank telescope. It's actually 100 meters in diameter. This is actually the second most movable man-made structure. The first was the Chernobyl cover that they built to actually cover the nuclear disaster. This is actually so massive. If you go there, you will feel the sheer size of it. So it's a massive dish, and we use this antenna to search for artificial signal. The other telescope we use is actually an optical telescope. I mentioned about radio, but we shouldn't really limit ourselves in radio. We should search the entire electromagnetic spectrum. It's just that only radio and optical actually passes through atmosphere, so we will first try and search there. Obviously, in future, we will try to explore gamma rays and X-rays as well. So in optical, we have a telescope which we use to search for signals in optical domain, in light. We have another telescope in Australia, which is called Parkes Telescope, which is also as big as the Green Bank Telescope. So how do we search? How do we actually search for signals? So our biggest challenge to search for signals from extraterrestrial intelligence is to distinguish that signal from our own signal. For example, all our mobile phones, if you go to a radio observatory, they might ask you to turn off your phones. The reason is that all our radio devices actually interfere. They are so strong that any particular astrophysical objects we try to study, the signal from there will be very weak compared to the signal that we transmit. So first of all, this is the biggest challenge for us. How do we separate the signal from ET from us? So in order to do that, what we do is that we look at a star for 5 minutes, and then we look away from the star. If we see that there was some signal when we were looking at the star, and when the signal goes away, that means that's a very good sign the signal is coming from the star. The reason to do that is because that the signal that we transmit actually always goes to the telescope no matter where the telescope is looking. So it doesn't matter where you look in the sky, the signal from your mobile phone, even though the telescope is not pointed towards you, will still reach the telescope by some way. So if we find a signal which is only coming from one star, not anywhere else, that's a very good sign that the signal is actually coming from the star. That means there is an intelligent life on that place which is transmitting this signal. The other thing we do, I mentioned that we also try to cover our own galaxy as much as we can. So what we did was that we actually divided the whole galaxy into a bunch of these small panels, and we searched for individual sections. This is not like a targeted star observation, but this is more like a detailed blind survey. So we do operate in both these modes. We do try to search for all different types of signal. This may be a little bit of complicated to you, but we try to search for various different types of signal. There are very, very complicated signals that one can search for. One of the very easiest signal that one can always search for is what we call the narrowband signal. All the natural occurring signals have very, very big bandwidth. They actually happen at multiple frequencies. Only the artificial signal that we transmit, happen to be a narrow band, happen to be actually concentrated in a very small frequency range. So this is what we call a narrow band signal which is concentrated entire energy into very small band. So these are the kind of signal that we search for. If there is a narrow band signal coming from a star, that's a very good sign that that signal is not a natural signal. That is generated by any artificial, that is generated by intelligent life, by an artificial technique. In fact, this is an example of a detection of a Voyager spacecraft. In fact, Voyager spacecraft transmits extremely narrowband signal. So in order to kind of verify our system, we routinely observe Voyager spacecraft, and we detect signal from Voyager. Not just that, this is a very complicated problem. So in order to search for different types of signal, we need to look at all the different varieties of signal, which is very hard for a human to do, even which is very hard for a computer program to do. It's hard because ultimately when you write a computer program, you still have to look at the data, you still have to verify the data. So what we thought is that we should do it in a more automated fashion as possible. So we have employed a whole lot of machine learning, artificial intelligence, in order to search for this signal. So we have trained a lot of computers to look for types of signal that we are interested in. And we can do this almost in real time. So as soon as the signal comes to us, we can actually find it. So because of this new development in machine learning or artificial intelligence, we are able to do this search more effectively. So the question remains, after doing all the searches, what do we expect to find? How many intelligent civilizations are there in our own galaxy? Can we estimate that? Is it possible to get some number that, okay, what if we are looking for intelligent life, how many of them are there? So it turns out that there are ways by which you can calculate it, or you can actually roughly guess it. So how do you do that? This is what we know as a Drake's equation. It was named after by an astronomer, Frank Drake, who actually first initiated this discussion on this topic. And in fact, he was the first person to do this search. So that's why it was named after him. What it actually says is that don't get confused by this large numbers and equation. It's very simple. All we are interested in finding this number n. Number n is the number of intelligent civilization who can communicate with us. How do we find this number n? So number n, it turns out, is actually nothing but is actually a multiplication of number of different probabilities. So what are these different probabilities? So first of all, we'll look at what are the number of stars in our galaxy. Then we say that out of these number of stars, what is the fraction of star which can have planets around them? Then we ask this question, out of these stars, what is the fraction of stars which have Earth-like planet around them? Then similarly, how many of these planets can have life? How many of these planets can have intelligent life? Remember, having an intelligent life is not enough for us. They should be using radio waves, because remember, this experiment for detecting a radio waves. Maybe there is intelligent life on other planets, but they may not be using radio waves to communicate. So this fraction is how many of those civilizations use radio waves to communicate. And finally, the factor L, which is one of the most important factor, is that how long an intelligent civilization will broadcast the signal. If they broadcast only for a short duration of time, you are not happen to look into that part of the sky, you will completely miss it. So this is an important factor. If they broadcast for several hundred and thousands of years, you are more likely to detect it. So if you ask me this question, that what is the current estimate of number of civilization in the galaxy, that number varies quite a lot. So if you look at there are two different types of arguments you can do. One is a very pessimistic argument where you assume all this parameter to be very low, and then it turns out that there maybe we are alone in our own galaxy. There is no other life. Or if you look at a very optimistic view, you take that, okay, every planet that can have life on it will have intelligent life, will be able to communicate, then they will be able to communicate with us. That's an extreme optimistic view. If you take all that, then there are hundreds, thousands of life in our own galaxy, which is very good. So maybe the number is somewhere in the middle, which is still not bad. That means that we still have to do a more thorough search, because obviously, as what Carl Sagan has said, the only significant test of existence of extraterrestrial intelligence is an experimental one. Although we can write all these numbers, we can make models, we can make theories about it, but we will not know until we do a thorough search. And that's what we are doing. That's what we are trying to do. That's what we with the SETI community or with the Breakthrough Listen, that's what the experimental project, that's what we are trying to do. So I show you a little bit of animation here. So let's say we are living, so how do you actually do this experiment? So all the things that I talked about, I will summarize it here. So we are living inside this galaxy. Let's say that there is a life on this side, and it started broadcasting. This circle actually represents a broadcast signal. Not just one place, there are multiple places which started broadcasting. If I go into the more detail, let's say you look at this part of the sky. There is some planet there. On this planet, life exists. After some time, life became intelligent. They developed technology, and they started broadcasting radio waves. Now, this radio waves, as I mentioned earlier, actually travels to space. So not just this place, but there are other places which actually can also have similar signals. So all of these intelligent life is broadcasting signal. Now we are sitting somewhere here using our radio telescope. We are pointing our radio telescope towards some part of the sky, along with we are also broadcasting our own waves. Now this radio waves, when it reaches us, when it reaches our radio telescope, we would detect it. For example, this is one of the telescope in Green Bank. Let's say it's sitting and observing a part of the sky. When the signal comes, we will obviously able to detect it. Similarly, if the telescope is Parkes telescope is observing some part of the sky from which the radio waves come, we will be able to detect it. So this is sort of summarizes the whole thing that I was trying to emphasize. So this is how we search for intelligent life. Now, you are all young students. You have this question. If you do not, I would really urge you to think about this, that how can you contribute? How can you make contribution to this field? So there are various things that you can do. If you want to, and most of these things are actually we have designed it for undergrads, for school kids. So in fact, if you go to our website, you will find all the different literature. You will find all the information about how to look for signals. We have all the data available to download. So if you are using your computer, you can download the data. We have the softwares also. So in fact, you can use our software or write your own, whatever you like, and you can look for signals. Or if you don't want to do that, if you want everything to run automatically, you can download SETI at Home. SETI at Home is a screensaver which you can just fire when you are not using your computer. It actually automatically downloads the data, and it analyzes the signal. Has any of you ever heard about SETI at Home? Just one person. So this is very good. This actually was one of the biggest effort happened in a couple of years back. It actually won the award of largest computation ever. The amount of computing we were able to do by the shared computers using volunteers was so much that if we ourselves decide to do all that, it will take us 100 years. But using volunteers' computer, we were able to do all that within a few years only. So it actually came out in a Guinness Book of World Records. So I would urge people in this audience to also help us search for signal using SETI at Home. And there are some rewards for that as well. So I give you an example of one of the high school students who was working with us. He's a high school student, but he was so interested in working and looking at the signal from intelligent life, he downloaded most of our data, and he analyzed it, and he published a paper. And this just came out a few weeks back, that this is the paper, I think the resolution is not very well. This is the paper he published. It also came out in the news. And if you're interested, you can just search our Berkeley channel. You will see a video of him discussing about his search. So there is no limitations. You don't necessarily need to be a scientist. You just have to have interest in this. Most of the stuff that you want to do is already there. You can help us do this search. And by that, I will just end by a final sentence from our sponsor, that a mature civilization, like a mature individual, must ask itself this question: is humanity defined by its division, its problem, its passing needs, trends, or do we have a shared face turned outward to the universe? This actually highlights this point that why is this question so important? So I started my talk by saying that, are we alone in the universe? And the only way to answer this question is by doing a search for it. Thank you. Yeah, a good question. So that's why I mentioned that type of signal we search for are something that the nature doesn't produce, as far as we know. For example, one of the signal that I mentioned is this extremely narrowband signal. Nature does not produce extremely narrowband signal, the type of signal we search for. It's only by using artificial technique, using by artificial transmitter, you can produce this signal. So there are types of signal that we typically search which nature doesn't produce. So how do we define from which point to billion year? First of all, universe is 13.7 billion years old. We are only 5 billion years old. That means that there is enough time in the universe, there is enough time in the galaxy for life to evolve to an intelligent stage. We are very young in that way. So there was a huge amount of time that has already passed. So obviously what we are trying to search for is already evolved intelligent life, not some life which is just starting to get evolved. Obviously we have no way of knowing about that. So typically when we look for signals, we try to look for signal from intelligent life, which is already far evolved than us. Because remember, it takes a huge amount of time for signal to reach us as well. So for example, if there is a civilization in some other part of the galaxy, if they transmit a signal, it takes several thousand years for signal to reach here. By that time, the civilization might be gone also. So by the time we receive the signal. So it's completely possible. But this is the hypothesis that we expect that since given enough time, universe is old enough that there should be intelligent life already existing by now.
Have humans broadcasted any messages to Earth?
Outside, yeah. Good question. So far, we have limited ourselves in deliberate transmission. The reason is that who will speak for Earth? Currently, there is no one single governing body which can speak for the entire humanity. It should not be a job of the US to transmit a signal. It should not be a job of China or India to transmit a signal. Unless and until all the countries and all agrees that this is an important thing we should transmit, I think we shouldn't do it. That this is a job of the entire humanity, not just one country. So until we reach that kind of globalization, we should not transmit. So far, the transmission has been very limited. There were some individual attempts. There was one very famous signal that was broadcasted from Arecibo telescope that I mentioned ago. That was only for like a 70-second. Now remember, if you really want to make sure that the other civilization detects you, you should transmit for hundreds of years. You should continuously keep transmitting. That hasn't happened. And I think it will take several years before we are in that stage where we can deliberately send signals to our nearby neighbors. Any question?
There have been instances when extraterrestrial creatures have visited Earth. Are we able to track them?
Well, as a person working in the SETI field, we do not really accept any of the arguments or the evidence presented to us that has ever happened. You're probably talking about the UFOs. So people in the SETI community or in the larger scientific community do not really accept UFOs as a genuine scientific fact. UFOs are more about a human perception about a phenomena. Sometimes there are phenomena that we don't really understand, and we kind of mark them as UFOs. Not everything that we can't identify necessarily need to be alien. So yeah, I don't think so that in a larger scientific community, people do accept UFO arguments. So I don't think so we have been visited by aliens so far. At least we don't have any evidence for that.
So is there a possibility of an alien apocalypse?
I hope not. I hope not. But we can't really say, right? I mean, we have just started exploring our neighborhood. We really have no idea about what type of life is out there. But it seems that if life is a type of life which destroys, they probably would have destroyed themselves already. How do we survive? We could survive if we achieve global peace, right? That means that we are a peaceful civilization. If you want to progress further, if you want to keep progressing in technology, if we are peaceful, we will be able to do that. But if we fight among ourselves, we will destroy ourselves, we will have no future. So if, let's say you talk about intelligent life, if they have evolved for thousands and thousands of years, they are probably peaceful. That's why they were able to evolve for certain stage. Otherwise, they would have destroyed themselves already. So that's one of the arguments people put forth, like the type of the signal if you're trying to search for, they are probably peaceful civilizations.
The argument that it plays that we ourselves on Earth are sending very few signals outside, can we flip the argument the other way around? The other planet wherever there is civilization,
Yeah.
they too feel the same,
Yeah.
hence they limit their communication, hence we are not able to identify them.
Sure, sure. Definitely. But I said that we are not yet sending signals. I never said that we should never send. Yeah, it's just a matter of time, I would say. As I said, we are a very young civilization. We started broadcasting in like just 70 years or so. And until and unless we have this global agreement that what we should do, we are not sending signals out there. But I'm sure that will happen in future. I'm sure we will deliberately send signals in very near future. But that hasn't happened so far. It could be the case for ET as well. We have definitely no way of knowing. But we would hope that by this time they would also achieve this kind of globalization, this kind of agreement that in order to communicate, they should deliberately send signal. So this is obviously an hypothesis, but you are absolutely right. It could be true that they might not be sending signals. So in that case, what we think is that even though you are not deliberately sending signals, but there is a leakage radiation, we could still catch that. Although the leakage radiation might be weak, it may not be as strong as a deliberate signal. So if we make our telescopes more sensitive, so future telescopes, for example, that's coming up online, they will be so sensitive that they will be able to detect leakage radiation so far away from other systems. So even though they are not deliberately transmitting, if there is a leakage radiation, we are also leaking our own radio waves. We cannot stop that. So that means that it's possible that other civilization might also be leaking radio waves which we can capture. So that argument is still can work out. Yeah. Yes, you talk about the wow signal. Wow signal was detected in 1993, I think. That was long back. So we detect wow type of signal almost every day. Unfortunately for that particular case, it got so famous for some unknown reasons. But I don't think so in anybody in the SETI community actually agrees that that was a genuinely signal from ET. There are some ways of checking that. You can, first of all, for us, in order to say this is a genuine signal, it has to be verifiable. It has to be persistent. It has to be constant. So even if you look at, again, the same part of the sky a few minutes later, it should be there. That didn't happen for the wow signal. The wow signal disappeared in a very few short time. So people argue that wow signal was genuine ET signal, but I don't think so the larger SETI community accepts that. If you ask about the question about sending something, I don't think so we have ever broadcasted something toward that direction in a very dedicated manner. Individually, people might have tried and attempted to do that, but I don't think so it's true that we try and do it every year. Even if there is say a civilization out there, it might take several hundred, thousands of years for signal to go and reach there. So it's not possible that you send a signal and you try to wait for the response, because signal will take thousands of years to reach. So there is no two-way communication. So there is no reason for us to send signal back if we receive something. Yeah.
Actually connected to what you were just talking about, that this time gap between receiving and sending signal. So what's really our hope in terms of investing so much on this?
Yeah.
So what are we hoping to gain from this?
Just one question, that are we alone in the universe? That's it. Yeah.
That question itself.
Yeah.
Right? Why are we investing so much to find this?
Are you not interested in that question? as a scientist, I mean, when I was a kid, this was a question that I was wondering about a lot. Like, are we really alone in the universe? Is there aliens out there in other star system? And this is a very fundamental question. Like, there are very few fundamental questions that we have asked the science. One is that how universe was created. Second is, are we alone in the universe? Third thing, where the universe is going, right? So there are some of these are very fundamental questions. It actually answers the question about humanity itself. For example, if you find life outside, that means that we are not unique. Life is not unique. And if you don't find life outside, that is also very important. That is telling us that we are unique. We should preserve ourselves. We should take care of our planet. This is a very unique place. So there are lots of reasons to actually people are curious about this question. Not just like finding life, but there are other questions related to our own self, I guess. Yeah. Yeah. Yeah, you mean detect, those spacecraft could detect life on somewhere else? Oh, yeah, oh, sure. Yeah. For example, Voyager can easily detect life on Earth because we broadcast signal to Voyager. Telemetry data, for example, it sends it back. We also can easily send signal to Voyager, which Voyager can very easily pick out. So, yeah, floating around. So unless you search for it, there is no way for us to kind of deliberately send a signal. So, Yeah, so obviously, but it's leaking, but unless you are actually deliberately searching for it, you will not find it, right? Like, for example, we are sitting here, there is a radio waves falling on us right now. We don't know what radio waves this are falling. I mean, there is a satellite going overhead, which is broadcasting radio waves. We have no idea about it, but if we have a radio antenna right now, if I point a radio dish upward, I could listen to that, right? So I think the same argument goes for something else in the sense some other ways of communication, not electromagnetic waves. So that comes to this. So what we are trying to say here is that let's try to search for things that we know of. We can talk about it. For example, people argue that what if the alien is trying to communicate using gravitational waves, right? I mean, using the radio telescope, you will not be able to detect those signals. But I would argue that if you talk about the energetics, the amount of energy that's required, for example, to send a gravitational wave is so enormous. You can do it very easily using radio waves. So there are arguments in favor of using electromagnetic, especially radio waves, to communicate over larger distances. You talk about some unknown science, I have no idea. I mean, if there is an unknown medium by which we can communicate some other science that we haven't really explored so far, maybe, but so far we will try to do the search in what science we have right now. No, no, thank you very much. It's important. Yeah. Yeah.
You said that you put a statement that aliens can also, extraterrestrial, right? They can like send signals with other than radios, like gravitational waves and all. Are we like trying to find out ways to detect that?
That's what the discussion was. We are currently trying to do with the science we know. So far we know about one way by which we can communicate very easily. So we are first trying to do the search with that way. If we do this search for like 100 years, 1,000 years, we don't find anything, we can explore other ways so far. But so far, so much of the search has happened, it's very limited. So first of all, we would like to search what's the easiest way, what's a low-hanging fruit, like what's one of the easiest ways we can communicate, and we are trying to do it with that first. Yeah.
Little off topic, but when you started the session, you talked about something called as the habitable zone.
Yeah.
How do you determine what is the habitable zone? No, like the range of it.
Yeah. So it actually depends on.
Size of the star too. So how do you?
So it also depends on the size of the star. It actually depends. So if the star is more bigger and it has more higher temperature, the habitable zone will be further away. So habitable zone is actually the range of temperature. I mean, it's a very loose definition. Obviously, it's not. One would not. I mean, cannot be very certain that you will find life only inside the habitable zone, right? So, but this is a very loose definition. This is just for our own understanding's sake. We were trying to find Earth-like planet which has liquid water on it. So you want to find those kind of planet, you try to look for the planet which are not so close to the star or not so away from the star. When I say not so close, not so away, it obviously depends on the type of the star as well. If the star is more brighter, that distance will be different. And if the star is more dimmer, that distance will be different. But there will always be a range of distance where you will have liquid water to exist. And that's what we call the habitable zone. Yeah. Yeah.
Do in the future find concrete evidence of extraterrestrial life, how would that affect us?
How does it affect us?
Like what would we do with that information once?
Right. I guess I would say that I will go and get a Nobel Prize if I find life first. But other than that, there are a lot of different things that we'll ask this question. Finding life is not the end of it. We would like to know more about it. We would like to know that if we detect a signal, is there any information in it? Obviously, we would not be able to understand every information over there. It will take us years and years in order for us to decode the signal, in order to understand what's out there, what is the message that they are trying to communicate with us. If you understand that, that kind of tells us a lot about their own culture, their own mathematics, their own science. That actually opens a whole new domain. That means that whatever the science we do, whatever the mathematics, 1 + 1 is 2 universally true. We know that. If they also speak the same language of mathematics, that's a very good sign that everything that we are trying to do is universally accepted. Something that we are doing right now has a meaning universally. And that kind of puts us in a good perspective that we got a signal from somebody which is not close to us, which is so far away. That means that life itself is not unique. That means that that's not just one of the examples. There are other places where life could equally be existing. So there may be hundreds and thousands of life out there in the galaxy, which is a very interesting idea. That means that one day, if we evolved enough, we could even travel to those places. And we could even, explore our own galaxy in that way. So possibilities are limitless in that way.
Yeah, but if we find extraterrestrial life and we're able to understand information,
Yeah.
and we realize that they've developed far more than we have,
Yeah.
if it accelerates our development at an unprecedented rate, can that be potentially dangerous?
If it comes to a wrong hand, yes. I would guess, I hope that won't happen. I hope that we are mature enough when we do make a detection or when we do decode the information, we are mature enough to use it in the right way. I would still think that is still highly hypothetical. I don't think so that we will get an Encyclopedia Galactica, something like that, over the message. If they are trying to send us a signal might be very simple, which we can easily understand. If you put a lot of information, it could make the signal a little bit more complicated to detect. So for the first thing that they would try to do would be making signal as simple as possible. Maybe they will just send us a beat 1, 1, 1, 2, 2, 2, something like that. So something that simpler will tell us something about their mathematics, but certainly will not be beneficial in terms of advancing ourselves. There are obviously a lot of science fiction on that. So I would not, I don't think so that I can argue against that, but I still hope that we are, at that time when we do decode the signal, we are mature enough to use it wisely. It's up to your generation. It will take years and years, even if you detect a signal, to decode it. Yeah. Are you? Okay. Well, if they are emitting gamma rays, we may find them in a couple of years. So far, as I said, our search is very limited from the ground. All the search we have done so far is from radio and optical, but that doesn't limit ourselves to search in other domain. So in future, we will definitely be searching in gamma rays as well, but it's just a matter of time. Right now, we don't have a technology. We don't have that much amount of funding and resources available to us to search in gamma rays. So I hope in future we will be able to search the entire electromagnetic spectrum, including gamma rays. So if they are trying to communicate using gamma rays, we would be able to find it as well. Yeah. 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 Certainly. So there is an idea which is floating around for quite a while now to actually put a dish on the far side of the moon. Because what happens is that moon is an excellent, provides an excellent shielding from our own transmission. So if you put an antenna on the far side of the moon, it actually blocks all the radiation from Earth, large amount of radiation, although there will be some radiation going around. But you will be able to block a huge amount of radiation coming from Earth itself. So you will be able to limit the radio frequency interference in your data, which is one of the biggest challenge we have so far. So that's a very good, I mean, of course, people have already realized that, and there's already some amount of thinking going on in that direction. But in terms of funding and resources, that's a massive project. Currently, it takes millions of dollars to send even a 1 kilogram of spacecraft into space. So even sending something like to the moon, it will be more expensive, sorry. Yes. Yesterday they landed on the far side of the moon. It's for the first time they've landed somebody has landed on the far side of the moon. So it's a hopeful future, I would say. But maybe it will take another 50, 100 years or so. Yeah. Yeah. I didn't get it. To look for ET? Yes. Right. Far side of the moon in the sense? Yeah, the other side of the moon, other surface. You know the moon is only facing one of its side to us. So the other side is not actually, it never actually comes in front. So all the radiation from Earth, actually, if you have a telescope on the other side of the moon, it actually gets blocked. And that side will never face Earth. And putting a telescope in space is very expensive. You can't have 100-meter dish in space, so you won't do that. But it's possible to have a ground telescope on moon, something which is stationary on the surface. So that's much more easier than having a 100-meter dish in space.
Yeah, so everybody's thinking about contacting aliens, but then what if you finally get in contact with an extraterrestrial race, which is highly advanced and more evolved, but then they see us as a potential threat? You have something to do against that?
Unfortunately, we have nothing to stop against that. We are already leaking radio waves. So first of all, I already mentioned this one, maybe I will emphasize that. We are not trying to deliberately send signals right now, okay? So we are not in that threat that we are inviting others to attack us. Something that we can stop is obviously the radio leakage. The radio leakage is already happening. If there is a civilization in close proximity to us, they already know about us. And that's something we can't really do anything about. All we are trying to do is that if there is intelligent life outside, if they use radio waves, can we detect and find their evidence? Even if we find the evidence, I would not say that we will send something back. I don't think so that it will be very easy for us to kind of collect a message and send it back to them. It will take years and years to signal to reach there. So I don't think so it will be a very feasible communication. So I wouldn't say that it's a communication. It's more of like so what we do is a very passive search. So it's not an active search. We don't really receive a signal and send something back. But about the threat, I don't know. Stephen Hawking was one of the guys who was actually warning us as well that this could be a potential threat. But there is something we can't do anything about. If the life is advanced enough, they would know about us already.